Hello students, welcome back to my YouTube channel Rouser's class. In the previous class we discussed about IIT questions, and I hope the remaining questions are solved by you. In case if you have not watched the video, please go through the playlist and solve those questions. They are very useful questions. And today we are going to discuss about Graham's law. It is Graham's law of diffusion. Graham's law of diffusion or effusion also. Actually this topic is not included in CBSE, but yes, questions are being asked in JEE, NEET or IIT exam, right? So that's why we need to learn this one. So here first we need to understand what is the meaning of diffusion or effusion. Diffusion means mixing of. It is a mixing of two or more gases on their own. Yes, that process is called as diffusion, which means here you are taking a closed container here, and in this you are taking A gas and B gas, and these gases are mixing on their own. That process, the process of mixing is known as diffusion. Then effusion means what? Effusion means coming out. Suppose if you make a small pinhole here, you made a small hole. Now the gases will diffuse out. That is called as effusion. Effusion means escaping of gases from high pressure through a pinhole. That process is known as effusion. Means you made a small hole here, the A gas and B gas will come out through this hole, and that process is known as effusion. So diffusion means coming inside and effusion means going outside. Understood this one? Yes, it is the meaning of diffusion and effusion. Now diffusion and effusion, which one will do fast? Means if you have a two or more gases, like I have a hydrogen gas and oxygen gas, so which gas will come out very fast? That we have to check. So according to Graham scientist, what he said is the rate of diffusion means mixing, or rate of effusion, symbol I can give R. Rate means speed. The speed of diffusion or speed of effusion is inversely proportional to square root of its density. Means if density is high, then mixing will be slow. That is a very simple concept, you all know very well. So if density is high, so which means it is a heavier gas. So if density is high, then what happen? Mixing process will be slow. That means the rate of diffusion is inversely proportional to square root of density. Now from this I can say R1 by R2 is equal to under root d2 over d1. So d2 means density, or rather I can say vapor density here, and d1 density of second gas and density of the first gas. This is the formula number 1. Now from this formula we can modify this, as we know vapor density of any gas is equal to 2 into its molar mass. Yes, correct? We have studied in class 11th beginning first chapter, vapor density is twice of its molar mass. So now we can say R1 over R2 is equal to under root, yes, sorry, it's a molar mass is twice. So vapor density is molar mass divided by 2. So here what can we write? Molar mass M2 over 2 divided by M1 over 2. 2 get cancelled, which means under root M2 by M1, which means the rate of diffusion is inversely proportional to, again, molar mass. Rate of diffusion is inversely proportional to molar mass. So this is another formula. Now suppose you have two gases. So like I give you two containers at a different condition, pressure P1, here pressure P2. So here it is a hydrogen gas and here it is oxygen gas. So it is asked to compare the diffusion. So which one will enter very fastly? So here we can have the condition, we can say when two gases at different pressure are present at a different pressure, then the rate of diffusion is proportional to pressure, which means the container which is having high pressure, there the diffusion process will be very fast. So rate of diffusion is directly proportional to pressure as well as inversely proportional to its density. Density is also important. So you can say R1 by R2 is equal to P1 over P2 into, is the density is inversely proportional. So what can you write? D2 over D1. So this is the case. This is the very unique formula in case if the gases are at a different pressure. Similarly, you may ask, sir, if the gases are at a different temperature, then suppose it is a gas at temperature T1, this another gas at temperature T2. So in that case, sir, what can we do? Yes, the rate of diffusion is directly proportional to temperature. Suppose it is a 40 Celsius, it is 80 Celsius. So here diffusion is very fast. So in that case, I can say the rate of diffusion is proportional to absolute temperature and of course inversely proportional to density. So now what can we write here? R1 by R2 is equal to T1 by T2 into square root of D2 over D1. If you are a smart student, you can also proceed further. You can also say that, sir, T1 over T2 into under root density, here you can say M2 by M1 because density is proportional to molar mass. So these are the different formulas which we can use. I'll write at the summary also. So at the end, these all formulas are useful for numericals. Clear? This is the Graham's law of diffusion. See, what is the Graham's law of diffusion? Diffusion means mixing of gases, which means coming inside. Diffusion means the gases coming inside. Effusion means escaping outside. So gases are going outside, that is called as effusion. So as per Graham scientist, that whether the rate of diffusion or effusion is inversely proportional to its density. Density means vapor density, because you know if density is high, so mixing will be very slow and the rate of diffusion will also be less. So rate is inversely proportional to density. So R1 by R2 is equal to under root D2 by D1, and from that you can get M2 by M1. And if gas are at a different pressure, if the pressure is more, diffusion will be more. That's why rate is proportional to pressure, but as usual inversely proportional to density. And if you have a two gases at a different temperature, then diffusion will be fast at higher temperature, which means rate of diffusion is proportional to absolute temperature and inversely proportional to square root of density. So these are the diffusion formulas. Note down this. Now, another formula for rate of diffusion. So the rate means it is like a speed. Rate is like a speed. So speed, what is the formula for speed? Distance over time. Similarly, rate of diffusion is similarly volume of gas over time taken for diffusion. So volume of gas over time taken for diffusion. So the rate of gas is equal to V by T. So rate is proportional to V by T. So as per this formula, what can we write? R1 by R2 is equal to under root V, it's not under root, under root is not there. So V1 by V2 into T2 by T1. So don't get confused here. It is a time. T is time. It is not absolute temperature. So this is another formula. So this is all about Graham's law of diffusion, which is over. It's a very simple one. So I'll write the summary here. Summary of this Graham's law of diffusion. So which is very useful for numericals. The rate of diffusion R1 by R2 is equal to under root d2 by d1, right, which is equal to under root m2 by m1, where m is molar mass. It is a pressure. If you have a pressure, p1 by p2 into under root d2 by d1, or temperature, if it is there, d2 by d1 into temperature T1 by T2, which is equal to V1 by V2 into T2 by T1. So these are the set of formulas you can use in many numericals. If you can see, last 5 years there are 6 questions in JEE, IIT or NEET examinations. Very, very important topic it is, Graham's law of diffusion. Now, application. The application part of this, I'll tell you very simple thing. So application of Graham's law of diffusion. There are many applications. When we see numericals, you will understand. So first point, I can easily see, suppose I have a balloon. So this is a balloon, let us say. So this balloon is kept in a container having hydrogen gas. It's kept in a balloon in a container having hydrogen gas. This balloon is tied one. So inside air is there. So outside hydrogen is there. Now if I make a small pinhole in the balloon, what happens? So in this pinhole, when you make a pinhole in this one, so what happens? Means whether the balloon will expand or shrink, or it remains same or burst at once. So that kind of questions can be asked. So here what you have to do is the rate of diffusion. So I can apply the formula, rate is inversely proportional to molar mass, right? So here hydrogen molar mass is 2 gram per mole and air molar mass is approximately 29 gram per mole. So now as per this rule, the speed of diffusion is more for hydrogen, which means if you make a pinhole here, hydrogen gas will enter into the balloon before the air get expelled out. So which means, so here the rate of diffusion of hydrogen gas is very, very greater than the rate of diffusion of air, which means hydrogen gas will enter very fast than the air going outside. Therefore after some time what happen is balloon swells up. It will not shrink. Generally students think that it will burst or it will shrink. No, it will swells up. So that kind of questions can be asked. Second thing is about questions type I'm asking. Suppose there is a long tube. It's a big long tube, and here at one end you are placing ammonia NH3, and at another end you are placing HCl at same time. Both are kept at the same time. So whenever these two mix, ammonia and HCl, ammonium chloride will be formed, dense white fumes. So question is, where do we notice the dense white fumes? So where do we notice dense white fumes for the first time? So here you see ammonia gas molar mass is 17 gram per mole and HCl molar mass is 36.5 gram per mole. So which means its mass is very high and its mass is low, which means the speed of traveling of ammonia will be very high. So ammonia will travel very fast than HCl. So which means these two, when HCl is traveling to this distance, so ammonia will travel more. It means we will see the fumes near, HCl terminal. Understood? We will not see fumes exactly at the middle. We will see the HCl fumes near HCl terminal. Even if you want, you can find the distance also. Let us say the total distance is 100 meters. Let us say the total distance is 100 meters. This distance is x, and then this distance is 100 minus x. Right. So as per the rule, the rate of diffusion is inversely proportional to molar mass. So the rate of diffusion means R1 by R2 is equal to under root M2 by M1. So R1 means rate of diffusion. What is that? Rate means distance covered. So time is same here. So here rate means speed. Speed means distance traveled. So here distance traveled by first gas, it is x, upon second gas it is 100 minus x, which is equal to under root M2, molar mass of the second gas, it is 36.5 upon molar mass of the first gas, which is around 17. So let us solve this. Approximate calculation I am doing. So if you want exact, you can do with calculator. So this is approximately under root 2.1. Approximately 2.1. So which means x by 100 minus x is around 1.42. So x is equal to 100 minus x into 1.42. So which means x is equal to 142 minus 1.42x, which comes, it is a 2.42x is equal to 142. X is equal to 142 over 2.42, which means around 60 or 63, something 63 meters, which means ammonia will travel 63 meters and the remaining 37 meter will be traveled by HCl. So which means ammonia, how much distance it is traveling? It is traveling 63 meters and HCl is traveling around 37 meters. These are approximate calculations. So in this way, we can easily do numericals based on Graham's law. And in the next class, I will solve about the IIT questions and NEET questions based on this topic. So I hope you liked this class. So if you have any comment to say, please put it on the comment box and share with your friends and let it spread to the maximum people. Thank you guys. Thank you and take care.